Hey everybody, this week's episode of Still Untitled is brought to you by Automatic. Automatic is a tiny device that you plug into your car. I actually use one for my car, and it brings your car into the 21st century. Works with any car made after 1996, and installation takes literally seconds. Fits right into that onboard diagnostics port, and when you pair it with your phone, with either an iOS phone or an Android phone, it can keep tabs on your driving habits, your fuel expenses, find out what the check engine light means in plain English, automate your home using Nest or If Then Then That, and you connect Automatic to the apps you use every day, from everything from expense filling to fitness trackers and even crash detection. Automatic will detect a crash and even call for help for free, and a human will stay with you on the line until help arrives. So go to automatic.com and use the offer code Untitled when checking out. The normal price is $100, but the holiday price is $80, and Still Untitled listeners can get it for $70, $69.99. Buy it before Christmas and get free FedEx 2-day shipping, and there's a 45-day return policy. So it's pretty great. Check it out. It's automatic.com and use the offer code Untitled like this podcast. And now on with the show.
Welcome to Still Untitled, the Adam Savage Project. I'm Will.
I'm Adam.
And I'm Norm.
And joining us today, we have a very special guest from NASA.
What?
NASA. We have the CTO of NASA, Dave Miller, joining us. Thank you so much for coming by, Dave.
Well, thanks for having me, and I can't think of a better place to talk about space exploration than The Rock.
A prison.
In the prison.
Space is just full of rocks. So Dave, you are the Chief Technologist of NASA.
That's right.
The CTO, so you oversee, can you give a little explanation of what you do and what you oversee?
Well, when I first arrived, they told me it's an up-and-out organization, and I had no clue what that meant. But it really means that I focus on long-term strategy and things like technology transfer, how we interact with other companies and transfer the technology we do. We also track emerging space, but probably we also roadmap the various technologies we're going to do. But probably the most important is advising the administrator on all things technology. There's a good sort of comparison I can make from who's seen The Martian?
Oh, yeah.
Yeah.
And who's read the book?
Yeah.
Got some readers still, that's good. So in there, I think he declares himself a space pirate.
Yep.
Yeah.
Okay, so let me use that as a way to describe who I am. I think
Nice intro.
Yeah, I think of myself as the parrot on the pirate's shoulder. So I provide advice to the leadership in the agency, and as long as I keep giving good advice, I stay on that shoulder.
So it's like, want to use ion engines.
Exactly.
Amazing. Wow. So you mentioned roadmaps. We love The Martian, and we've talked about it extensively on our podcast. And one of the things we looked about, because it's talking about somewhere maybe 30 years, 40 years into the future. And that's what you're thinking about, those technologies, all the things that can get us to Mars and beyond.
That's right. So right now we're building the world's biggest rocket. It's called the Space Launch System, or SLS. It's going to be bigger than the Saturn V. But once we have that in place and the Orion capsule that goes on top, we have to start building all the tools that are going to help us get out to Mars and work productively and get back home. So we're working on a round trip in the 2030s.
And in addition to that, as a technologist, you're also interfacing these technologies with other space agencies around the world that we're cooperating with. Every time you're developing something for the future, you're looping in other partners, right?
Absolutely. Space exploration is really an international endeavor. If you look at all our science missions, rovers on Mars, or Cassini out at Saturn, or our Earth science, or our human exploration space station, it's all an international endeavor. So we coordinate with the international community every day.
You seem like a calm person, but this sounds like the most stressful and all-encompassing job I could imagine. I mean, it's overwhelming how the facilities all over the world, the technologies. It's got to be an incredible amount to just put into your head.
Well, the trick is, and I realized this early on, you don't have to know it all. You just have to know who knows it. And you got to have a good black book. That's the trick.
Okay.
What are those technologies that you're most excited about?
Boy.
Or you see that as most promising?
There's a whole bunch. Some of them are exciting, but they're also to try to get us through some terrifying events. So if anyone watched the Curiosity landing on Mars?
7 minutes of terror.
Yes, terror. Yeah. 7 minutes terror. So a thing to think about is that at the surface of Mars, the thickness of the atmosphere is about 1% Earth's, and so it's like our atmosphere at 100,000 feet. So it's really hard to get a bite on that atmosphere. So we're working on a lot of different ways of doing this, like inflatable. HIAD's a name for it, but inflatable deceleration devices that would work at supersonic speeds. It's just a series of events that is 7 minutes of terror, and we're trying to figure out, since we have to land much larger payloads on the surface. Curiosity was 1 ton. We have to get a lot more than that to support humans, so you really got to get a bite on that air, and we're going to have to rely a lot more on retropropulsion, basically firing engines to get that last sort of kilometer per second down to so we can land softly.
Wow. And what do you need? Do you know what? I mean, I don't mean to put you on the spot, but what do you need to land softly? What kind of impact speed are we talking about? I know the Soyuz hits pretty hard compared to like our Apollo capsules and the shuttle and stuff like that.
Well, you want to get it under about 5 meters per second, and then let the shock absorbers sort of take the rest of it.
Wow. We've talked a lot about Mars recently on Still Untitled, and I mean that's only part of what NASA does. A large part of what we've seen recently with like New Horizon is deep space exploration, beyond the inner orbits and probes that go to Saturn, Jupiter, and the other outer planets. Can you tell us a little bit about what's going on there? I know there's some challenges facing those programs.
Yeah, it's when you look at space science in NASA, it's one of 4 of our directorates. It's broken into 4 pieces. There's study of Earth science. There's study of our sun, which drives a lot of our weather on Earth. There's study of the rest of the solar system, and then there's the study of everything else, which is astrophysics. And so, anyone been watching what's going on with Pluto?
Yeah.
Pluto fans out there? So 6 months ago, all we had in our images was a dot. And now look at all these landscapes. Anyone see anything missing on Pluto that you would have expected? Craters. There's very few craters. What's causing that? That says to us that that's a fresh, sort of renewing landscape. But it's it's in the deep freeze of the outer solar system. It's something we're still trying to figure out what's going on with that's renewing that surface on rather short timescales. Another thing, Hubble took another deep field image. So if you don't know what the deep fields are, we turned Hubble to look at some of the darkest parts in the skies. Like I think the first deep field was in the Big Dipper, which is one of the darker parts of the skies, and let it just sit there and sort of collect light for a long period of time. And what we see are thousands of galaxies.
If you haven't seen these pictures, they're absolutely astounding.
Yeah.
If you want to feel the smallest you're ever going to feel in your life, imagine the darkest spot in the sky, and then you look at the picture of what's there, and it's just it's breathtaking.
The first time you guys did that, I sat down with my kids. They were probably 10 or 11 at that time, and just the sound, I mean, that when I showed it to them, the sound, when they realized that looking at this dark spot was thousands of galaxies, each composed of billions of they were, I mean, it's wonderful how accessible that is and how, it's just an incredible illumination.
To borrow a phrase from sci-fi, it's really full of stars.
I mean, so Hubble is one of the great telescopes, right? Yep. There's a handful of others, and one of them has been in the news a lot lately for finding a bunch of exoplanets.
Yeah, the little satellite the little telescope that could, Kepler. Mm-hmm. So it's been looking at, a little history, going all the way back to 1995. In 1995, we knew of 9 planets, and then we demoted poor old Pluto. But that was in 2006. But now we know of over 2,000. And there's probably 3 more that are on the yet-to-be-verified list, 3,000 more on the yet-to-be-verified list. And Kepler was only looking at about 1% of the sky. And so we can, in that 1%, we've also identified a handful, maybe 8 or 10, that are planets about Earth size in what we call not the technical term, the Goldilocks Zone.
The part
means,
is not too hot and not too cold.
Yeah, it's not too hot to boil off the water, and it's not too cold to freeze it. It's just right, liquid water on the surface. And so when you take that 1% and you see how many we found and you extrapolate that around the sky, we estimate there's 11 billion Earth-like planets in the habitable zones in our galaxy alone. So anyone know the Frank Drake equation? So, it's, when I first learned about it, it's the product of a bunch of numbers that leads you down to how many intelligent civilizations could communicate with us. And it seemed like, well, who knows any of these parameters? It's an interesting equation, but we've been marching along and starting to answer that. And one of the key ones that we're answering now is how many, Earth-like planets, not only planets around other stars, which we think is on average is at least one, but how many Earth-like planets in a habitable zone are around each sun-like star. And so we're really starting to knock that down, and the news is good. We're still in the billions of possibilities to look for intelligence.
And the amazing thing about the way Kepler works is, unlike the earlier methods we found in the first exoplanets with like gravitational wobble by seeing Jupiter-sized masses
7
moving
ways
around.
to find a planet.
Oh,
Right.
7 now?
Uh-oh, you're not going to make me
Oh,
lose.
no, it's okay. Go to Wikipedia, guys, if you want to
One
find
of
it.
them is go take a Polaroid snapshot and bring it home. But no, but there are a bunch of ways.
Yeah, I mean, you're able to find very small bodies in incredible, unimaginable distances.
So after you do that, then there's an even more unimaginable thing we do, and that is if the planet has an atmosphere that is transparent enough, kind of like our atmosphere, that when the planet goes in front of its star, from our perspective, and it dims the light that we see, that's how we know it's there, then the light refracts through that atmosphere, and we see it. We see that there are additional molecular absorption. I don't want to go too techie here, but more.
You can nerd up,
absorption.
it's fine.
So then you can start to say, does it have water? Does it have oxygen?
Oh
Might
my
it have
gosh.
oceans? Might it have things? So let me put this in context.
So you're able to do a spectroscopy on the
Yeah.
refraction that's
right.
From dozens or hundreds of light years away?
Yeah. Well, the signal's strong. It's not me personally.
You know we're
I
NASA,
know
right?
who does it. I know who
I
does
should
it.
have, it's rocket scientist.
So let me give you a
Space is in
comparison.
our name.
You probably saw the. I assume this whole crowd went out and saw the supermoon lunar eclipse.
Yeah.
Yeah.
It's not black. It's red, and that's because the sunlight, all the sunrises and sunsets from all over the globe, all that reddish light was being focused down on the moon. So think of that as what's happening at these stars, and that light's coming to us, and we can look at that and start to tell about characteristics.
I'm
of
just a
those.
little bit smarter now than I was 10 minutes ago.
Yeah, that's amazing. Okay, so we talked a little bit about deep space with Pluto. One of the things I learned this week, we had a live show earlier this week, and I found out we don't have any deep space missions planned to speak of after, well, we have the Mars 2020,
That's right.
and then after that,
And I think Juno arrives at Jupiter in
anybody
about
know?
next year or so. Next summer.
next summer, okay.
There's the person that knows everything. Feeds me information.
But
Yeah.
then after that, we don't have anything planned.
We
for
have
that.
things in extended mission as well. You
Okay.
know, like New Horizons now has a new target. It probably goes by some numerical name that I don't know. But
Something up in
it's
the-
heading out into the Kuiper Belt to explore new objects. The James Webb Space Telescope, which is going to look in the infrared, 6 meters in diameter, going to unfold out at Earth's sun L2. Launches in 2018 and is going to see back to about first light, sort of ignition in the universe.
So hold on, it can
further
see
back
back
in
to the
time.
Big Bang?
No, I think it sees back to around when stars first ignited. I think that's what's called first light, but you need the chief scientist here to answer all those.
We'll get them next week.
You're just the chief technologist.
That's right.
Can we talk about spin-offs? Will and I were
sure.
talking about earlier, and when Will was a kid, you were reading a magazine. NASA had a magazine called
It
Spinoffs.
was a
Right.
little pamphlet we got.
Yeah,
That's
about
right,
the
when I was in grade
technologies
school.
that trickled.
Every year that comes out talks about probably 1,000 or so spin-off technologies into non-aerospace sectors that NASA makes every year, and we publish these. You can download them from our website, NASA Spinoffs. There's a lot of examples of things that we've spun off. And
Stuff like Velcro and Tang,
wrong.
all the normal stuff.
You know, I thought NASA did Tang, and as a kid, I drank gallons of that stuff, and I thought that was going to qualify me to be an astronaut. found out no.
They did
wasn't
no
wasn't
Tang.
good enough. No, Tang
Okay.
didn't do it. You needed more qualifications than that. But one that really caught me by surprise is in the development of nutrients for astronauts. They came across a natural source for omega-3 fatty acid, which is a key ingredient of 99% of infant formula worldwide. So I would have never figured that would have been most of you have smartphones, that little camera inside. The electronics for that was developed through the miniaturization work for imaging systems on NASA satellites. Anyone have memory foam mattresses?
Yeah.
Yeah.
Oh, yeah.
Okay, memory foam. Those winglets on the end of airplane wings, anti-skid
Really?
runways.
Hold on, what did the winglets
The
do?
winglets. You want me to get nerdy?
Yeah, get nerdy.
Okay, so
You're in good company.
So
this
high,
is the
high
second
pressure
show.
under the wing, low pressure on top of the wing, and at the tip of the wing, the high pressure wants to sneak around and come up on the top side, and that induces that energy into a vortex, a vortice, and so that helps to prevent that leaking of the high pressure into low pressure.
So does it increase like efficiency or something?
Yes,
Oh,
increase
wow.
efficiency. Have you been looking at some of the jet engines coming out, and on the back of the cowling, there's sort of this serrated edge? Mm-hmm. It looks cool, right? But it's more than that. It's actually for noise reduction.
Really?
Yep.
Huh.
So
And this is
there's-
all NASA.
This is all NASA.
I imagine those technologies trickle down and then feed back.
That's
Consumer
right.
technologies also go back.
Oh, that's right. Yeah, there's a lot of tablets and things on station, and there were on shuttle as well. So, there's a nice sort of feedback there. And let me give you another example. Agriculture. Probably in the old days, the farmer would wake up and go milk the cows. Now they log on. They can get remote sensing data about what part of their farm, actually down to subsections on each field, where they need more moisture, where they might need less fertilizer, things like that, so they can really plan out their efficiently how to take care of their crops. A lot of the seeding and harvesting machines are now automatic and run by GPS and can run day and night. There's a mission called GRACE, and I think there's a GRACE 2 coming up, which are 2 satellites that they fly around, and when they change their distance slightly, it's in response to variations in the Earth's magnetic field. And they can measure, because of that motion, this is mind-boggling, because of that motion, they can measure the depth of the aquifer in the San Joaquin Valley to like a centimeter.
What?
So
Wow.
they've been tracking the depletion, and it's not even by looking at the San Joaquin Valley. It's just seeing what the missing or the effect of, the variation in gravity that 1 centimeter of water would have made on the motion of those satellites.
Just the missing mass.
Right.
Wow.
Right.
Wow.
So I'll bet there's more than one, but what are some of the most significant technological challenges NASA faces moving into the future?
Boy, one of them is keeping up with the pace of what's happening, in the broader community. We're going to Mars in the 2030s, probably first to orbit and then to land, and trying to figure out how to plan that out so that we can best integrate with the various what we call emerging space companies. Some of those companies are no longer emerging; they're going prime time now. And what I say to my students, I'm on leave from my university. I say to my students that we're in the modern age of Howard Hughes, where people make a fortune in a non-aerospace field and then spend it all on their passion for aerospace. And we really want to fan the flames on that and see how we can best work with those companies.
And when you need a civilian to go up to space, I'm just letting you know, I'm volunteering right now.
You want to be the first one?
Happy to. I'll be the 5th. I don't care about the number.
Now, Adam, I sent a letter to Ronald Reagan when I was in 4th grade that said, hey, I'd like to be an astronaut. I'm cool with taking the risk. I'm 8, maybe 9. I can't remember. You said something interesting there that I missed. You said we would first go to orbit around Mars. Is the plan really to send people to orbit, take the long trip to Mars and orbit, and then come back, like we did with the early Apollo missions?
Well, Apollo 8 did that.
Yeah.
So did Apollo 10. Right.
So
you want to take a stepping stone approach. You don't want to try to have too many miracles that happen on one particular mission.
it's such a long trip, though.
That would be rough.
Are you changing your place in line? Should we move you back?
I mean,
I think Adam's going to move up. He's going to move
I'll
up
take the
one.
chance
so
on
that's fine.
17 or 18.
They get a patch. They get a patch that says, "I went to Mars and only circled it."
All I got was this lap. Yeah.
Well, Apollo 8 did that and around the moon, and that was one of the most impactful missions we had. And talk about a Hail Mary pass. If you know the history of Apollo 8, the LEM was late in being developed, so they pulled it off. It was supposed to be an Earth orbit test of the lunar module, and they heard that the Russians were probably going to make a try, and so they said, okay, we're going to reconfigure this mission on the fly, and it was the It was the first launch of the Saturn V, and there were 2 test launches before it, and the one just before it had a double main engine out, so the next flight goes to the moon with people on board. That's a real Hail Mary pass.
It was a Jim Lovell
Yeah,
fight, too,
and it
right?
took the photo of, Bill Anders took the photo of Earthrise,
Yeah.
which,
Right.
changed our whole perspective. Yeah,
All
that's
of
probably
humanity
yes.
minus 2 people in this one
That's
picture,
right,
yeah.
that's right. Minus 3.
Well, 3, yeah.
Don't forget to ask about the super
Yes,
secret.
Oh,
that's
yeah.
right,
Something
yeah.
secret happening tomorrow.
Super secret
Segue,
thing.
segue.
Super secret. I don't have a segue. Just tell me what the super secret thing is.
Okay, so tomorrow, we've been thinking sorry.
Oh, no, it's tomorrow for you guys, but it'll be in the past for the people listening at home. So congratulations,
So if
live
you
studio
watch the movie
audience.
Interstellar, you'll understand this all. So, okay.
That's a documentary, right?
Segue.
Yes.
Right.
So we've been thinking that the best place to look for life outside Earth is probably at Mars. And that's probably still a very good shot because we're finding water and liquid water, and we're finding methane, and we found organic compounds in the fossil record at Mars. We're just getting really close. But the ocean worlds in our solar system, and there are a number of them, are showing a lot of promise. So Europa has an ocean under a frozen surface, and Enceladus, which I think is only like 500 kilometers in diameter, very near to Saturn, its southern hemisphere has sort of a bulge in it that's a bit of a deep ocean, liquid water, and it has geysers shooting out of it. Now, I don't know if you've seen those photos, but the Cassini spacecraft, which has been up there for 12 years now, going around Saturn, has flew through it, but tomorrow we're going to fly through it at an altitude of 30 miles.
Wow.
Right through it. And the last time we went through, it's got plenty of water. I mean, it freezes, it comes out, it's got ice crystals. But we've also measured organic compounds in it. So it's kind of like a soup. There's stuff coming out of that. It's a briny ocean. There's stuff coming out of there that if only we could detect life, and that's a good question. How do you do that? But that's a very promising place. And tomorrow, think of this. We're going to, with about a 1 mile accuracy, we're going to fly 30 miles above the surface of Enceladus, and we're flying it from a distance of 800 million miles away. That's called threading the needle.
That is thrilling.
So does Cassini have spectroscopy and stuff? Is that how you're measuring the compounds that are in the water, or is this too specific a question?
That's a good one for the chief scientist.
Okay.
But yes, something like that. So we can measure those kind of particles, those kind of molecules, but we don't have and I don't know what they are.
It wasn't
We can actually
designed.
measure life. It wasn't
Cassini,
designed.
12 years ago
Right.
when we launched, it wasn't designed, or
Right.
20 years ago when we launched, it wasn't
Right.
designed
It was
to fly through
designed,
the geyser.
yeah.
You mentioned Europa, and it makes me think of the movie Europa Report that we were
Oh,
talking
yeah.
about earlier, where they find life. And I know you watched The Martian.
Spoilers, by the way.
Yeah, it's all.
That wasn't from me.
Do you get to watch science fiction movies, and are there ones that you enjoy? And what about it from your perspective as the CTO of NASA? What are the things you
Yeah.
look out for?
Well, while I was eating the classic combo box, I was watching Interstellar on my tablet. I think that's the second time I've watched it. But I like Contact. I think that one.
yes.
That one is timeless.
Yes.
And I also, I love watching Discovery Channel and those. That's not sci-fi, but I can't get enough of watching the science of it, because that's really what they do, is go into the science of Discovery and Science Channel and so forth, about what's going on throughout the universe and space science and all that. But the thing is, to work on the technology alone is insufficient. You really got to understand the science side of the problem so that you know what kind of problems you're trying to solve. And so working in collaboratively is an important thing. So one of the things I think that we're starting to make strides in the university setting is having students that start to learn both the science and the engineering side of the coin, so that they can speak each other's language and work better when they get to NASA.
So this is one of the things I love asking folks from NASA, but we have a lot of listeners who are younger, who are students, whether in high school, elementary school, or later. If people want to come work for NASA and help us get to Mars and beyond, what should they be studying? What should they be doing? What should they focus on?
Well, it's gotten so broad. I mean, it used to be, aeronautics and astronautics and planetary science and astrophysics, but, Now it's biotechnology, it's medicine. I mean, a lot of the work on space station is contributing to our knowledge of the humans and how they adapt and how that might apply to people on Earth. So there's a broad areas, even, law, international laws, treaties, policies,
Piracy, being a pirate.
Piracy,
Yeah,
that's
there you
right,
go.
that's right. So,
That checks out, right? He was totally right.
oh, he's totally right.
Okay.
Yes. Just throw a rope over the other person's spaceship and you got it, it's yours.
Okay.
Yeah.
I assume part of your job is to find stuff that's off the shelf and technologies that are off the shelf consumer stuff that you can then apply. I mean, one of the things that we were surprised by when we started working with folks that are working on orbit on occasion is how much off the shelf computer and camera gear and it's not like they're shooting with custom Hasselblads up there anymore. It's just Nikons and Canons and DSLRs that you have here. What's the most unusual thing that you've worked with qualifying to go to space?
So I'm going to use a communication trick. I'm going to give you one answer while I try to think about
That's
an answer
perfect.
to that one. The space station, when space station first was put together and permanently occupied back 15 years ago, to get hardware up on station, you had to go through arduous procedures, made sure everything was just right, and really made it custom, where right now, or actually in the last 5 years, we've been putting things that are up there much more, as is from terrestrial research laboratories. And that's really helped a lot because researchers are used to using microscopes and whatever, glove boxes and so forth in their labs on the ground. Might as well just get those up in space so that we can get them up quicker, get the research done, and that the researchers are used to using that kind of equipment.
Is it just making sure it's qualified for like the fire safety and all that stuff?
Yeah,
or?
yeah. Most of it is, the number one rule is don't hurt anything. Don't hurt the crew, don't hurt the space station, and hopefully don't hurt your own equipment.
But like laptops and iPads and Android tablets it's all just kind of up there and people are using it now,
I'm
right?
not going to pick a particular
Of course,
vendor,
of
but
course.
that's all right. Yes, yes. Smartphones and tablets and
Generics.
laptops and it's kind of like the shuttle where technology evolved and some of the best computing was actually in the laptops versus what was actually in the shuttle main computers in terms of computational power. But you have to be able to adapt that. So,
Very cool. I think we have time for one more if either of you guys have something.
weird astronaut stories, I can tell you.
But always good for weird astronaut stories.
That is exactly what I was going to ask for.
Sorry. Don't
No,
mean to put
yeah.
words in your mouth. So 2 stories. The second one's better than the first. So. I asked an astronaut, I came back from space station after 6 months on orbit, and I said, tell me something I don't know. And he said, well, when we land, we want to do 3 things. We want to kiss our family. We want to eat our favorite meal. These are the things you've missed. And we want to take a shower. And he said, I went to take a shower, and you start at the top, right? You lather your hair with the shampoo, and you have to close your eyes. And he fell down. And he realized he had to sit on the floor in order to do that. And the reason is, a lot of your balance is your inner ear, but another part of your balance is your visual. Well, your inner ear hasn't helped you at all for the last 6 months, so your brain shuts it off. Wow. It says useless sensor, shut it off. Wow. And then you get on the ground and you close your eyes and you just fall over. Wow. So here's the second one. So this is a shuttle story, so it's a bit of going back in history. But all the important stuff in the shuttle's kept in the bay, so they'd want the astronauts to stay along the hinge line of the shuttle bay doors, where they can't hurt anything. And their legs are way more powerful than they're actually more of a menace to equipment than they are useful for moving around. So what they would do is they'd have these handholds along the rails of the shuttle, along the edge, along those hinge lines, so they can move back and forth from the tail to the nose. And the shuttle would typically fly with its bay doors open towards the Earth, just for thermal reasons. So an astronaut was telling me, you're walking along on those handholds with your legs away, thinking I'm doing the world's best handstand. This is fantastic, going along. And then all of a sudden, your mind is missing that gravity cue about which way's up, and it flips. And then you realize I'm hanging 250 miles above Earth from this machine, which gives you pause for a moment, and then it flips again, and you go, I'm doing my handhold, and then it flips again.
That's why they have diapers.
That's right, exactly. I'll leave it at that.
I think that is as good a place as any to wrap it up. Thanks to the Bay Area Science Festival for having us out here on Nerd Night at Alcatraz.
Absolutely.
Thank you, all of you guys, for coming. The volunteers for the Bay Area Science Festival do amazing work at all of their events.
Can I ask
Of
one
course.
more thing? Part of my job is to help people figure out how you can help us, and we made one-stop shopping called NASA Solve, where we put prizes, challenges, crowdsourcing, all kinds of things there. So if you want to help us solve our mission, please go take a look and maybe earn some cash in the meantime.
That
So
is awesome.
NASA Solve? Just
NASA
Google?
Solve.
Okay.
Yep.
Fantastic.
No, web search. No.
Oh, well, yeah, no, Google. Sorry. Your favorite internet search engine.
Thank you.
The Google. The Google.
That'll do it for us this week. We're on every Tuesday. If you enjoy this, we're on iTunes and all the other, the internet podcast.
Exactly.
And we'll be back next week with another show. See you guys next
Dave
time.
Miller.
Thank you.
Thank you so much, Dave. Yes.
And I want to thank this week's sponsor of Still Untitled, which is Automatic. It's a device that you plug into your car and you can get really awesome data from your car, moving your car into the 21st century. Automatic is a small device, plugs into the onboard diagnostics port, and then pairs with your iOS or Android phone, and then you can get driving habits. You can track your fuel usage. It can help tie to other apps to plug into your expense filing or your fitness trackers. You can connect it to Nest. Super easy to use, really powerful, and it's available right now for $69.99 for Still Untitled listeners if you use the offer code Untitled. Order today and you get free FedEx 2-day shipping before Christmas. Thank you, Automatic, for supporting the podcast, and thank you guys for listening, and we'll see you next week.